The German engineers stood on the eastern bank of the Rhine, binoculars pressed against their faces, watching something that defied every principle they had learned in military academy. Across the churning water, American combat engineers were assembling what appeared to be a complete bridge from nothing more than prefabricated panels and pins. No cranes. No concrete mixers. No months of construction. Just men working with practiced efficiency, slotting metal pieces together like a child's puzzle, except this puzzle would soon carry 30-ton Sherman tanks across one of Europe's most formidable rivers. The Germans had blown every crossing for miles, confident that the natural barrier would buy them weeks, perhaps months. Yet here, less than 6 hours after the American advance units arrived, a functional bridge was taking shape before their eyes. One officer lowered his binoculars and muttered to his aide that what they were witnessing was impossible. The aide did not respond. He was too busy calculating how little time they had left before that impossibility became their doom. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow, I've saved something extra special for you. The military engineers of the Wehrmacht had been trained in a tradition that stretched back generations. German engineering was methodical, precise, and built to last centuries. Their doctrine emphasized permanence over speed, craftsmanship over convenience. When the German army constructed a bridge, it involved surveying teams, architectural plans, foundational work that could take weeks to complete properly. Stone and steel were shaped with care, concrete was poured and allowed to cure, and only after extensive testing would vehicles be permitted to cross. This was not merely practicality but philosophy. A bridge represented mastery over nature, a monument to human ingenuity that would stand long after the war ended. Speed was secondary to strength, and shortcuts were viewed with suspicion bordering on contempt. Throughout the early years of the war, this approach served Germany well. Their engineers had constructed impressive crossings over rivers throughout occupied Europe, each one a testament to their technical superiority. When they retreated, they demolished these structures with equal thoroughness, leaving nothing behind that could aid enemy pursuit. Every bridge blown was a calculated delay, forcing Allied forces to halt their advance while they figured out how to span rivers that suddenly became uncrossable chasms. The Germans understood the strategic value of these natural obstacles. Rivers were force multipliers, buying time for regrouping, for establishing new defensive lines, for bringing up reinforcements. A single destroyed bridge could delay an entire division for days, perhaps weeks if the river was wide enough and the current strong enough. In the winter of 1944, as Allied forces pushed deeper into German territory, the retreating Wehrmacht became increasingly reliant on this tactic. Every river crossing from the Seine to the Rhine was rigged with explosives. Engineers worked alongside rear guard units, placing charges at critical structural points, running detonator wires to safe positions on the far bank. The moment the last German soldier crossed, the plunger would be pressed and tons of steel and concrete would collapse into the water below. It was a strategy born of desperation but grounded in sound military logic. Without bridges, the Allied advance would grind to a halt. Their supply lines would stretch thin. Their momentum would evaporate. And in that pause, Germany might find time to regroup, to fortify, perhaps even to negotiate. The German High Command issued clear directives. No bridge was to fall intact into enemy hands. Demolition teams were given priority over combat units when it came to withdrawals. In some cases, bridges were destroyed even before retreating forces had fully crossed, sacrificing rear guard soldiers to ensure the Allies could not follow. The policy was ruthless but effective, or so it seemed. As American and British forces reached each demolished crossing, they indeed stopped. Engineers arrived with pontoons and timber, beginning the slow process of constructing temporary spans. German observers, watching from concealed positions on the opposite banks, tallied the days. 3 days for a minor river. A week for a major one. 2 weeks if the weather turned bad or if artillery could be brought to bear on the construction site. But then something changed. Reports began filtering back from frontline units that made no sense. American forces were crossing rivers far faster than anticipated. Bridges were appearing where none should exist, and they were not the flimsy pontoon affairs the Germans expected. These were solid structures capable of bearing the weight of heavy armor. At first, German intelligence dismissed these reports as exaggeration or confusion. Frontline soldiers under stress often misjudged distances and timeframes. Perhaps the Americans had simply found intact bridges that demolition teams had missed, or maybe they were using shallow fording points. But as more reports arrived from different sectors, all telling the same story, the pattern became impossible to ignore. In a command bunker south of the Rhine, a gathering of senior engineers pored over reconnaissance photographs and after-action reports. The evidence was undeniable. American combat engineers were constructing bridges at speeds that violated every known principle of military engineering. One crossing over a river in France had been completed in under 8 hours. Another, spanning a wider channel, had taken less than a day. Most baffling of all, these bridges were not temporary expedients. They were robust structures that supported continuous traffic, including the heaviest tanks in the Allied arsenal. The assembled officers struggled to explain what they were seeing. Some suggested the Americans must be using prepositioned materials, caches hidden by resistance fighters or left behind by retreating French forces. Others theorized that Allied air superiority allowed them to airlift prefabricated sections directly to crossing sites. A few simply refused to believe the reports, insisting that proper intelligence would reveal a more conventional explanation. But one veteran engineer, a colonel who had spent the previous year overseeing demolitions across occupied France, offered a different possibility. He had heard whispers from prisoners of war, fragments of conversation about something called a Bailey Bridge. The name meant nothing to most officers present, but the colonel explained what he had pieced together. It was apparently a modular system, a bridge that came in standardized panels that could be assembled by hand without heavy machinery. The design was British, developed earlier in the war, and the Americans had adopted it wholesale. Each panel was identical, each connection point uniform. Soldiers did not need specialized training or complex tools. They simply needed to follow a sequence, linking panels together in a predetermined pattern until a span emerged. The room fell silent as the implications sank in. If such a system truly existed, it represented a paradigm shift in military engineering. Traditional bridges required customization for each site, unique solutions to unique problems. But a modular system eliminated that complexity. The same panels that span a narrow creek could be multiplied to cross a major river. The same assembly process that worked in France would work in Germany. Standardization meant speed, and speed meant the Allies could maintain momentum regardless of how many bridges the Wehrmacht destroyed. For officers trained to think in terms of permanence and precision, the concept was almost offensive. A bridge assembled in hours seemed more like a carnival trick than serious engineering. Surely it could not bear real weight. Surely it would collapse under sustained use or heavy weather. And yet the evidence suggested otherwise. The colonel concluded his briefing with a grim prediction. If the reports were accurate, then Germany's strategy of trading space for time by destroying bridges was failing. The Allies were no longer being delayed by demolished crossings. They were simply building new ones faster than German forces could establish new defensive lines. The natural obstacles that should have protected the fatherland were being neutralized by a piece of British ingenuity that most German engineers had never heard of until that moment. The meeting adjourned with orders to gather more intelligence, to capture an intact Bailey Bridge if possible, to understand the enemy's capability before it was too late. But for many in that room, a seed of doubt had been planted. They had spent years confident in German technical superiority, certain that their engineering prowess was unmatched. Now they faced the unsettling possibility that they had been outthought not by some revolutionary breakthrough, but by a simple, elegant solution to a problem they had overcomplicated. The Americans were not building better bridges. They were building faster bridges. And in war, speed often mattered more than strength. As the officers filed out into the cold evening air, more than one cast a nervous glance toward the western horizon, where the sound of distant artillery rumbled like approaching thunder. Somewhere out there, American engineers were assembling another bridge, and the clock was ticking down on Germany's ability to stop them. The German soldiers dug into their positions along the riverbank, exhausted from days of retreat but grimly determined to hold this line. The river behind them was wide and fast, swollen with early spring runoff. Every bridge for 20 kilometers in either direction had been demolished according to plan. Engineers had done their work with typical German thoroughness, leaving nothing but twisted metal and shattered concrete jutting from the water like broken teeth. The natural barrier should have bought them at least a week, perhaps 2 if they could bring artillery to bear on any crossing attempts. Time enough to rest, to resupply, to dig proper fortifications. Time enough for reinforcements to arrive from the interior. The Americans would come eventually, but they would have to build their way across, and building took time. The first units of the American advance arrived late in the afternoon, their convoy of trucks and half-tracks grinding to a halt on the western bank. German observers watched through field glasses as officers surveyed the demolished bridge, gesturing at the river and consulting maps. For a moment, the scene unfolded exactly as German doctrine predicted. The Americans had hit an obstacle. Their momentum was broken. Now would come the inevitable delay while they figured out their next move. Some of the younger German soldiers permitted themselves thin smiles. Perhaps this line would hold after all. Perhaps the retreat would stop here. But then something unexpected happened. Instead of digging in or turning back to find another route, the American convoy began to unload. Trucks backed up to the riverbank and soldiers started pulling out long metal panels, each one perhaps 3 meters in length and a meter wide. More panels followed, along with smaller connecting pieces, pins, tools, and timber balks. Within minutes, the western bank was transformed into an organized staging area. Men moved with purpose, sorting materials into neat stacks, establishing work zones, laying out what appeared to be assembly instructions on large canvas sheets. There was no confusion, no hesitation. This was clearly a drill they had practiced many times before. German officers raised their binoculars, trying to understand what they were witnessing. The American soldiers were not engineers in the traditional sense. They wore standard infantry uniforms with combat engineer insignia, but they worked with a speed and coordination that suggested extensive training. Teams of 6 men would lift a panel, carry it to the water's edge, and position it according to shouted instructions from a sergeant consulting a clipboard. Other teams brought connecting pins, sliding them through holes in the panel corners and hammering them home with sledges. The sound of metal striking metal echoed across the water, a rhythmic clanging that carried an almost industrial quality. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. What struck the Germans most was the absence of heavy equipment. No cranes lifted the panels into place. No cement mixers prepared foundations. No pilings were being driven into the riverbed. The Americans were building entirely by hand, using nothing more than muscle power and simple tools. Yet the structure taking shape on the western bank was undeniably substantial. The panels locked together with precision, forming a framework that extended horizontally toward the water. Additional panels were added to increase the height, stacked one atop another and secured with more pins. Slowly, the shape of a bridge began to emerge, though unlike any bridge the Germans had seen constructed before. A German lieutenant scrambled back from his observation post to report to his company commander. His description of the American activity was met with skepticism. A bridge built without machinery, assembled from identical panels like children's blocks, completed in a matter of hours rather than days? The commander questioned whether the lieutenant had perhaps misunderstood what he was seeing. Perhaps it was merely a temporary platform for rafts, or a repair to some existing structure. But the lieutenant insisted. He had watched for over an hour, and the Americans were definitely building a bridge, and building it faster than should be possible. The commander decided to see for himself. Together with several officers, he moved to a concealed position overlooking the river. What he saw troubled him deeply. The bridge now extended nearly a quarter of the way across the river, supported by floating pontoons that had been positioned in the current. American soldiers worked on the span itself, adding panels to extend its reach while others prepared the next section on the bank. The operation proceeded with assembly line efficiency. One team would complete a section, another would float it into position, a third would connect it to the existing structure. There was no wasted motion, no apparent confusion about what came next. The German commander pulled out his pocket watch. He marked the time, then settled in to observe. If the Americans maintained their current pace, he calculated, they might have a span reaching midway across the river by nightfall. That was concerning but not catastrophic. His artillery observers were already plotting coordinates. Once darkness fell, they could shell the construction site, destroying whatever progress had been made. Come morning, the Americans would have to start over, assuming they were still willing to try. And each attempt would cost them time, would slow their advance, would give Germany the breathing room it desperately needed. But as the afternoon wore on, the commander's confidence began to erode. The American work pace never slackened. Fresh teams rotated in to replace tired ones, maintaining constant forward progress. When pontoons needed adjustment, specialized crews handled that task without disrupting the main assembly. When panels needed to be lifted into position over deeper water, soldiers simply added more men to the carrying team. Problems were solved immediately, often without any apparent orders being given. It was as if every man knew exactly what his role was and how it fit into the larger effort. By early evening, the bridge reached the midpoint of the river. German soldiers watched in growing disbelief as the Americans paused only long enough to establish a stable work platform before continuing. Portable lights were being set up on both banks, and a generator truck rumbled to life, its engine noise carrying across the water. The commander realized with a sinking feeling that the Americans intended to work through the night. His artillery could still disrupt them, but hitting a moving target in darkness was far more difficult than striking a stationary one. And if they succeeded in completing the span before dawn, his defensive position would be compromised. He sent runners to the artillery positions with updated coordinates and orders to commence firing at full dark. If they could not stop the bridge from being built, they could at least make the Americans pay dearly for their audacity. But even as he issued the orders, a part of him wondered if it would be enough. He had watched German engineers work for his entire career, had overseen construction projects that were models of technical excellence. What the Americans were doing should not be possible according to everything he had been taught. Yet there it was, taking shape before his eyes, defying his expectations with every panel added. As night fell and the first artillery shells began to fall near the western bank, the German commander made a decision that would haunt him. He called for his men to prepare for withdrawal. The bridge would be completed, if not tonight then certainly by tomorrow. Once it stood, American armor would pour across, and his understrength company would be surrounded and destroyed. Better to fall back now, to preserve his force to fight another day, than to sacrifice them in a doomed stand. His officers protested, pointing out that their orders were to hold at all costs. But the commander overruled them. There was no point holding a position that was already lost. As the company gathered their equipment and began slipping away into the darkness, the commander took one last look across the river. The American bridge was more than halfway complete now, illuminated by harsh work lights that turned the scene into something almost theatrical. Soldiers moved across the span like actors on a stage, their shadows long and distorted. The sound of hammering continued unabated, punctuated by occasional shouts and the deeper rumble of the generator. It was a scene of organized chaos, of controlled urgency, and it represented something the German commander was only beginning to understand. The Americans had not just built a bridge. They had built a system, a repeatable process that turned an engineering challenge into a logistical problem. And logistical problems could be solved with resources and determination, both of which the Americans possessed in abundance. The next morning, as dawn broke over the river, the Bailey Bridge stood complete. American tanks were already rolling across, their treads clanking on the metal decking, heading east into territory the Germans had thought secure. The defensive line that should have held for weeks had lasted less than 24 hours. And across Germany, in command posts and engineering offices, officers were beginning to realize that their understanding of warfare had just become obsolete. The shock of that first completed Bailey Bridge rippled through German military circles faster than the American advance itself. Officers who had dismissed earlier reports as battlefield confusion now found themselves confronting undeniable evidence. Reconnaissance photographs showed the spans in stark detail, metal frameworks stretching across rivers that should have remained impassable barriers. Intelligence analysts measured the structures from multiple angles, calculating load capacities and construction timelines. The numbers told a story that contradicted decades of German engineering doctrine. These bridges were not flimsy expedients. They carried tanks, trucks, and artillery without apparent strain. And they appeared within hours, not weeks. In a headquarters building near the Rhine, a specially convened panel of senior engineers gathered to examine captured materials. American forces had abandoned a partially assembled Bailey Bridge during a tactical withdrawal, leaving behind several panels and a complete set of assembly instructions. German technicians approached the materials with a mixture of curiosity and skepticism. The panels themselves were unremarkable at first glance, simply welded steel frameworks with reinforcing crossmembers. Each one bore stenciled markings indicating weight specifications and assembly positions. The connecting pins were equally simple, just hardened steel rods that slid through pre-drilled holes and locked with cotter pins. One engineer lifted a panel, testing its weight. 2 men could carry it comfortably, for could move it easily even over rough terrain. He examined the connection points, noting how the holes were positioned with absolute precision. There was no room for error in the assembly, no need for field modifications or custom fitting. Every panel was identical, which meant every panel was interchangeable. If one section became damaged, it could be removed and replaced without affecting the rest of the structure. The simplicity was almost insulting to men who had spent careers mastering complex structural calculations and site-specific engineering solutions. The assembly instructions proved even more revelatory. They were written in clear, straightforward language with detailed diagrams showing every step of the construction process. No advanced mathematics required. No specialized knowledge assumed. The instructions treated bridge building as a sequence of discrete tasks that any trained soldier could perform. Lift panel. Position panel. Insert pins. Hammer pins. Move to next panel. Repeat. There was even a section on troubleshooting common problems, written as if assembling a military bridge were no more complicated than following a recipe. A colonel who had designed permanent bridges across major European rivers before the war sat in silence, studying the documents. He understood immediately what he was looking at. This was not inferior engineering disguised as innovation. This was brilliant engineering that had solved a problem German doctrine had never properly addressed. The Wehrmacht had always assumed that bridges needed to be permanent or at least semi-permanent structures. The idea that a bridge could be temporary, rapidly deployable, and still fully functional had simply never been prioritized. German engineers built for posterity. The British, apparently, had built for practicality. The colonel pointed out several features that his colleagues had missed. The modular design meant that bridge length was infinitely variable. Need to span 30 meters? Use 30 meters worth of panels. Need to span 60? Use twice as many. The same components adapted to any situation. Furthermore, the system included variations for different load requirements. Single-story configurations for lighter vehicles, double-story for heavier tanks, even triple-story for the most demanding applications. Each configuration used the same basic panels, just stacked and pinned differently. It was elegance through standardization, a concept that German engineering had somehow overlooked in its pursuit of customized excellence. Testing began immediately. German engineers assembled a short span using the captured materials, following the instructions precisely. The work went slowly at first, slowed by unfamiliarity and translation difficulties. But even with these handicaps, they completed a 10-meter section in under 2 hours. When they tested it with a captured American truck, the structure held firm, showing no signs of stress or deflection. One engineer drove a Panzer across the span, half expecting it to collapse. It did not even shudder. The bridge performed exactly as advertised, and that performance was deeply troubling. Reports from the field continued to accumulate, each one adding detail to the emerging picture. American engineer battalions traveled with huge stockpiles of Bailey components, enough to construct multiple bridges without resupply. The panels were transported on standard trucks, stacked flat to save space. When a river was reached, the trucks simply unloaded at the site and assembly began immediately. No surveying required. No site preparation beyond clearing the immediate banks. The bridges went up fast because the Americans had eliminated every unnecessary step from the process. German commanders began receiving instructions on how to counter this new threat. Artillery units were ordered to prioritize engineer sites, to disrupt construction before bridges could be completed. Infantry was directed to establish positions overlooking likely crossing points, to harass work parties with small arms fire. Demolition teams were given additional explosives and told to ensure that destroyed bridges were truly impassable, not merely damaged. But these were reactive measures, attempts to compensate for a capability gap that German industry could not quickly close. Some officers advocated for Germany to develop its own modular bridge system, to copy the Bailey design or create something similar. Engineers drafted proposals, calculated material requirements, estimated production timelines. The numbers were discouraging. Germany's industrial capacity was already stretched thin, struggling to produce tanks, aircraft, and ammunition. Retooling factories to manufacture standardized bridge components would take months, possibly years. And even if production began immediately, training troops in the new system would require time that the collapsing fronts did not permit. The Bailey Bridge was not just a piece of equipment. It was the product of years of development, testing, and doctrinal integration. Germany could not simply replicate that overnight. Meanwhile, American engineer units continued their relentless advance. They bridged the Moselle, the Saar, the Roer, and dozens of smaller rivers whose names never made it into history books. Each crossing followed the same pattern. Arrive, assess, unload, assemble, cross. The process became so routine that engineer battalions began competing to see who could complete spans fastest. Friendly rivalries developed, with units trying to beat previous records. One battalion claimed to have erected a 60-meter bridge in just under 6 hours. Another boasted of assembling a crossing under direct artillery fire without losing a single man. German defenders who witnessed these constructions described them with a mixture of admiration and despair. One sergeant recalled watching American engineers work through a rainstorm, their hands slipping on wet metal but never pausing. Another remembered seeing a bridge section get swept away by current, only to watch the Americans calmly retrieve it and reassemble it correctly within the hour. The persistence was inhuman, mechanical, as if the soldiers had been trained to function like components of the very bridges they built. The psychological impact began to weigh as heavily as the tactical reality. German soldiers fighting along river lines knew their position was temporary. The Americans would bridge the obstacle, always had, always would. Defensive lines that should have held for weeks became mere speed bumps, delays measured in hours rather than days. The traditional comfort of natural barriers evaporated, replaced by the grim certainty that no river was wide enough, no current fast enough, to stop the Allied advance for long. In officers' messes and forward command posts, the discussions grew heated. Younger officers, those who had risen through the ranks during the war, argued that Germany needed to adapt, to learn from Allied innovations rather than dismissing them. Older officers, schooled in pre-war doctrine, resisted such suggestions as defeatism. They insisted that German engineering remained superior, that the Bailey Bridge was merely a temporary expedient that sacrificed quality for speed. These debates went nowhere, circular arguments that changed no minds and solved no problems. But among the combat engineers themselves, those who actually worked in the field building and destroying bridges, a different understanding emerged. They recognized professional competence when they saw it, even in an enemy. The Americans had identified a critical problem, rapid river crossing under combat conditions, and engineered an elegant solution. There was no shame in acknowledging that. The shame lay in the fact that German engineering, for all its vaunted superiority, had failed to anticipate this need. They had built bridges to last centuries when what the modern battlefield required were bridges that lasted just long enough. One German engineer officer, captured during the fighting along the Rhine, spoke candidly with his interrogators about the Bailey system. He admitted that upon first hearing about it, he had laughed, convinced it was propaganda or exaggeration. But after witnessing a bridge assembled in front of his defensive position, after watching his carefully prepared demolitions become irrelevant because the Americans simply built new crossings faster than he could destroy old ones, his laughter had died. He told his captors that the Bailey Bridge was perhaps the single most important tactical innovation of the war, more significant than any tank or aircraft because it kept armies moving when they should have been stopped. The interrogation reports made their way up the chain of command, eventually reaching Washington where they were filed away with thousands of other documents. But the engineer's assessment was accurate. The Bailey Bridge had fundamentally altered the calculus of modern warfare. Armies no longer needed to pause at every river, no longer needed to wait for engineers to construct elaborate permanent crossings. They could maintain operational tempo, could keep pressure on retreating enemies, could exploit breakthroughs before defensive lines solidified. Speed had always been valuable in war. The Bailey Bridge made sustained speed possible. As winter turned to spring in early 1945, the Rhine itself loomed as the final great natural barrier protecting Germany's heartland. The river was massive, cold, and fast-flowing. Its bridges were among the most heavily defended structures in Europe, ringed with anti-aircraft guns, protected by elite troops, wired for demolition at multiple points. German planners believed the Rhine would slow the Allies for months, buying time for some miraculous reversal of fortune. When the Ludendorff Bridge at Remagen was captured intact through a combination of American aggression and German demolition failure, it seemed like a fluke, a lucky break that would not be repeated. But the Americans did not need more intact bridges. Within days of the Remagen crossing, engineer battalions were assembling Bailey bridges at multiple points along the Rhine. The Germans destroyed every other bridge in their sector, collapsing spans into the water with thunderous explosions that sent up geysers of spray. It did not matter. The Americans simply moved a few kilometers up or downstream and started building. One Bailey Bridge appeared near Wesel, another at Mainz, a third at Worms. Each one took less than 24 hours to complete. Each one immediately began funneling Allied armor and infantry across the river. German artillery hammered the crossings, scoring direct hits that destroyed sections and killed engineers. The Americans patched the damage and kept building. Luftwaffe aircraft, increasingly rare as fuel and pilots dwindled, attempted desperate bombing runs against the bridges. A few bombs found their marks, but damaged Bailey sections were simply disconnected and replaced with fresh panels. The bridges absorbed punishment that would have destroyed traditional structures, survived because their modular nature made them reparable in ways that conventional bridges were not. On the eastern bank, German defenders watched the crossings with fatalistic resignation. They knew what was coming. They had seen it before at a dozen other rivers. The bridges would stand, the tanks would cross, and the defensive line would crumble. Some units fought with determined ferocity, knowing they could not win but refusing to surrender without a fight. Others melted away into the countryside, unwilling to die for positions that were already lost. The Rhine, that ancient river that had marked boundaries and defined territories for millennia, proved no more effective at stopping the American advance than any of the smaller streams that preceded it. Among the German soldiers pulling back from the Rhine crossings, conversations turned philosophical. They discussed what it meant that their vaunted engineering prowess had been outmatched by what appeared to be a simple, almost crude solution. Some blamed the Nazi regime for focusing on weapons production while neglecting logistics and support equipment. Others pointed to the broader industrial might of America, noting that the Bailey bridges were just one example of how American manufacturing had overwhelmed German craftsmanship through sheer volume and practical innovation. A few simply shook their heads in wonder, unable to reconcile their pre-war assumptions about German superiority with the reality unfolding before them. The bridges kept appearing. Each one a testament to British ingenuity and American execution. each one a refutation of the doctrine that had guided German military engineering for decades. And each one carried more Allied soldiers deeper into what remained of the Third Reich, bringing the war closer to its inevitable conclusion. The Bailey Bridge had not won the war by itself. But it had ensured that rivers, those natural allies of defenders throughout history, could not save Germany from the consequences of the conflict it had started. That alone made it one of the war's most consequential innovations, respected even by the enemy who suffered from its effectiveness. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.